Hello everyone, welcome back to the channel. In this video lecture, we'll solve this problem insert interval. So this is a lead code medium problem. In this problem, we're given an array of non-overlapping intervals. That means any two intervals in the array do not have any common point, where each interval is represented by two integers representing the start of the interval and end of the interval. Then intervals are sorted in ascending order by the starting time, and we are also given a new interval containing the start and end point, and the task is to insert this new interval into the intervals array such that the intervals array stays sorted in ascending order by the starting time of the intervals, and even after inserting the new interval, we still do not have any overlapping intervals. That means all the intervals must remain independent even after inserting an extra interval into the array. And we have to return that modified intervals array after the insertion of new interval. Let's see the input and output format. In the input, we will be given the array of intervals and a new interval, where an interval is defined by two integers representing the start, and one of the integers represents the start of the interval and another one represents the end of the interval. In the output, we have to return the intervals array containing the non-overlapping merged intervals. Fine. Let's see the constraints of the problem. The length of the intervals array goes up to 10,000, and each interval contains two integers, while the range of the interval goes up to 10 raised to the power 5. So that means the largest interval that we can have can be from 0 to 10 raised to the power 5, and the intervals are sorted in ascending order by the starting time, and the length of the new interval is also 2, containing two integers representing the start and end of the interval. Let's better understand the problem statement using an example. So here is an example input. So this is the initial intervals array containing two intervals 1, 3 and 6, 9, and this is the new interval that we want to insert into this array. We can see that these intervals are independent, or there is no common point or integer between these intervals. So these intervals are represented by these red lines. First interval starts from 1 and ends at 3, while the second interval starts at 6 and ends at 9. We can see that both these intervals are non-intersecting or non-overlapping, while we have to insert an interval starting from 2 and ending at 5, represented by this blue line, which is indeed overlapping with the first interval of our array. Therefore, so how do we solve this problem? The first step is to insert this interval into the right position in the array. So what we did here is that we inserted this interval, which is a new interval, into the second position in this array because we want our intervals array sorted by the starting time, and it is sorted by the starting time. But what is the problem with this answer? You can see that these intervals, that is namely the first and the newly inserted interval, has this part as overlapping. So this has it is the overlapping segment, this one, from 2 to 3. So that means the first two intervals here, they are overlapping, so we have to merge them. You can see that 1, 3 and 2, 5, these two intervals, they can be merged into one interval starting from 1 ending at 5. So this array is modified to this array. So this is our new modified array. It satisfies both the constraints of the problem, that is, it contains the non-overlapping intervals which are sorted by the starting time. Fine. So what is the strategy to solve this problem is that we'll be given a set of intervals, which is the input intervals array, and a new interval. All we have to do is to find the suitable position in this array where this interval can be inserted. For example, in this array, the new interval must be inserted after second interval here, because 4 is just greater than 3, so that all the intervals stays in ascending order of the starting time. This is the first step of the solution. Then the step 2 of the solution is the merging step. So what is the merging step? After we have our set of intervals, we have to check if there are intersecting intervals or not, or overlapping intervals in the array or not. For instance, after we have inserted our new interval into this array, we'll be having this type of configuration where 4 5 will be where 4 to where the interval where the new interval is represented by this red line. So here we can see that this newly inserted interval overlaps with the second, third and even fourth interval here. Here we can see that these four intervals are overlapping. So this is a newly inserted interval and these four intervals are overlapping. So we can merge these four intervals into one interval, that is 3 to 10. Here you can see. So this can be replaced, all of these four intervals can be replaced with this new interval that starts from 3 and ends at 10, giving me the final array as. So that is the final set of intervals that we would have, and this is the answer. Let's see the implementation for this approach. So this is the insert and merge function. So it takes in the intervals and the new interval that we want to insert. It first calls the function insert interval, which simply insert this new interval into the intervals array at appropriate position. After that, we declare our answer array, which will store the final intervals. Then we find the size of the intervals. Then we iterate over all the intervals here, and then we start from each interval, ith interval, and we try to check in this while loop the number of intervals after I, starting from I plus 1, which overlaps with this current interval. So that's what we are doing here. Then finally we push the answer. Finally we push the current interval, which is so we merge all those overlapping intervals into this current interval, and finally we push that current interval or the merged interval into our answer array. So this merge intervals function is used to merge the current interval with the ith interval, because these two intervals are overlapping. Finally, we return our answer right from here. Let's see the definition of these insert interval function, does interval overlap, and merge intervals function. So this is the definition for insert intervals function. It takes in the intervals array and the new interval which we want to insert. It takes this boolean variable initialized to false. It is used to check if the new interval has been inserted at some position in the intervals array or not. So here we iterate over the intervals array. We check if the starting of the current interval is greater than the starting of the new interval. If this is the case, then ith position is the right position. Then this ith position is the right position for this new interval. So we insert the new interval at that position. So we move the iterator by I positions and we insert the interval at that position, and we mark this boolean variable as true to check that the interval has been inserted, and we break out of the loop right from here. Otherwise, if this variable is still false, that means we haven't inserted the interval into the array, so we push our new interval right here. Let's see the definition of merge intervals and does intervals overlap function. So here we can see that the merge intervals function takes in two intervals a and b. So here is the scenario. We have the first interval, this is interval a and this is interval b, and to merge them all we have to do is to take minimum of these two starting points, which is this one, and maximum of these two ending points, which is this one, which will give me the new combined interval. It starts. So that's what we are doing here. Then this is the function, boolean function, which is used to check if these two intervals a and b overlap or not. So here what we do is we take the minimum of the ending points of these intervals, that is minimum of these 2 points, which is this one, and maximum of the starting point of interval A and B, which is this one. So if the intervals overlap, then this area is non-zero, which is indeed the case here, and hence these two intervals are overlapping. So that's what we are checking here. If it is greater than or equal to 0, that means the intervals are overlapping, otherwise they are not overlapping. So let's discuss the time and space complexity for this solution. So you can see that inserting the interval initially will take linear time, because we have to traverse all the intervals in the intervals array in the worst case. Then inserting into the list at the right position also takes linear time. Then iterating over the intervals and merging them with intervals ahead of it takes linear time again, because the merging step is used to merge the overlapping intervals, and in the worst case we explore each interval exactly once. So therefore it is taking linear time complexity. So the overall time complexity is linear, that is big of n. Then the space complexity is constant if we do not consider the answer array that we are using to store the intervals. Fine. So let's see the implementation of the above solution. So this is the solution class. So in this solution class, let's first create the insert function, which takes in the intervals array and the new interval, and it returns the set of intervals which are non-overlapping and merged. So initially we push this new interval into this intervals array at the right position. Then I declare my answer array, which will store the final merged intervals. Then I iterate over all the intervals in the intervals array, and then I find my current interval, and I start from the current interval and I keep merging the intervals ahead of it until they can be merged using this function merge interval. Then I decrement I by 1 so that the ith interval is not skipped in the next iteration. Then I push my current interval, which is the merged interval, into the answer array. And finally, I return my answer right from here. Let's see the definition of this insert interval function. So this is the insert interval function, which takes in the intervals and a new interval which you want to insert, declares a boolean variable and initialize it to false. Then I iterate over the intervals. I check if my ith interval, the start of the ith interval, is greater than the start of the interval which I want to insert. If that is the case, then I is the right position to insert, and I insert my interval at ith position. Then I mark my is interval inserted variable to true, because I have inserted my interval at ith position, and I break out of this loop right from here. Here I am checking if this boolean variable is still unmarked or it is still false. That is the case if I haven't found the appropriate position in the intervals array to insert the new interval. In that case, I push my new interval at the ending index. Fine. So let's see the definition of this merge intervals function, which takes in two intervals and merge them. So this is the merge interval function, takes in two intervals A and B. Simply return the interval after merging these two intervals. So this is the boolean function which is used to check if the two intervals A and B are overlapping or not. So this is the implementation in C++. Let's see the implementation in other languages. So this is the implementation in Java, and this is the implementation in Python. So that's all for this video. If you like the video, then do like it and make sure to subscribe to my YouTube channel and give your feedback in the comments below. I will see you in the next video. Till then, take care. Bye bye.